Go.
Hello, my name is Evan Cross.
I'm Ben Hinesley.
I'm Nate Nielsen.
I'm Sean Liu.
And this is our Lab 4 knee design for Mech 488.
So we designed a 4-bar non-gradual pi rocker mechanism, and it can rotate and slide. And the rotating range is from 0 to 120 degree. It stops at 0 and 120. And then we consider 4 scenarios: standing, walking, stairs, and squatting.
Some major components of this design are the femur, the tibia, the linkages, and the pins. So with our linkages, we provided additional support for the knee so that it can stop at 0 degrees when the person is standing still. And also the tibia, or the femur, has a patella-like extrusion on it in order to provide some additional support for the user.
For the force analysis, we used 4 different scenarios as mentioned before. For walking, we used 250 pounds at 0 degrees, and that gave us a factor of safety of 7.2, which leads to 1,800 pounds. For walking, we did a force analysis of 750 pounds at 15 degrees, and this gave us a factor of safety of 1.9, leading to 1,425 pounds. For the third scenario was climbing upstairs. We did a force analysis of 60 degrees at a force of 950 pounds. This led to a factor of safety of 1.5, which gave us again 1,425 pounds. And for the final scenario, we did squatting down, which was about 120 degrees. And at a force of 1,400 pounds, we got a factor of safety of 1.1, which gave us 1,540 pounds, which is well above the needed requirement of 1,250 pounds provided in the lab.
The knee is made out of 3 materials: aluminum 7075, ASTM A36 steel, and grade 5 titanium. The large components, the femur and tibia, are made out of the aluminum 7075. This is because it's lightweight and not much force is transmitted between these large components, except for thick areas where the aluminum would be enough. The 5 linkages are constructed out of the steel. This is because it needed to be slightly stronger than the aluminum, but still not strong enough to where it need to be something very expensive. And finally, the pins, the 4 pins here are made out of grade 5 titanium. This is because most of the stress is at this location in the form of shearing when the knee is in motion. Because the material needs to be very strong in order to support this load.
For cost analysis and quoting, a few different websites were used. For the top tibia, or for the top femur and bottom tibia connection parts, we used an actual representative from Eccentric Mold and Engineering. This top piece was quoted at about $840. This bottom tibia connection was quoted at about $550. The anterior linkages out of steel were quoted at about $113 from Xometry online quoting. These posterior linkages for constraint were quoted at about $116, and this middle and posterior linkage for support was about $235. And on McMaster-Carr, we found 24-inch stock 3/8 rod of grade 5 titanium was about $67, and this would cover about 2 knees material worth. The total cost came out to about $2,150. Limitations. As far as some cons of this design, we didn't get to test this actual design on an amputee, so we don't know how comfortable this might be. And it's currently scaled to the weight of a 250-pound person, so somebody who was a bit smaller might not need a knee this big. There are a few small pinch points towards the back here, but those could be easily avoided. There are no massive pinch points, which brings us into our pros. There aren't many parts, and the motion is rather simple of this design. This was our knee. Thank you for listening.